Uh, Welcome back. We're going to continue our study of quadratics. This is for Monday, Tuesday lesson. We talked about last week method 2, so go ahead and take a moment, solve this equation using our method 2. Pause me now. I'm going to keep going for time-wise, but go ahead, pause me, and then try to solve it, and then you'll see my work. Okay, so if x plus 5 squared equals 10, we're not going to factor. We know that we can do an operation to undo this square. And so our new operation that we can do, or not new operation, but something we can do to both sides, is to take the square root of both sides. Right? And the square root cancels out the square, which we're trying to solve for x, so we'll get the x plus 5 on this side equals, and when we take the square root of both sides, we talked about that we can have both a positive and negative answer we have to account for. So plus or minus, we introduce that symbol. Square root of 10. That's kind of like the new piece right here. And now we need one more thing to get x by itself. And we're just going to take away 5. So minus 5 from both sides, we get x by itself. And we have plus or minus the square root of 10 minus 5. And that's your answer. Can't do anything more with it. I talked about it that if you upper grade teachers like to have the whole numbers in front, or any kind of, not whole numbers, integers in front, even rational numbers, they want irrational second. Yep, and that's the do now. Okay. I'm going to be going fast here on this lesson, so pause me at any moment. I found out we have less time than I thought to learn the other two methods, but I do want to preview them with you. So this is Chapter 8, Method 3, and it's called Completing the Square, and this is the first part. We're going to do both parts today. So this new method, if you repeat after me, is called Completing the Square. Okay? And it's another way that you can solve quadratic equations, find the x-intercepts, find the zeros, all that good stuff. So it's another way to do it if you don't want to have to factor. Well, I guess you you kind of have to factor in this one, but not really. Okay, so let's take this as our example. We wanted to find the value of x that makes this equal to 0. So it's equal to 0, and it's something squared plus something minus 2. And we can't use taking the square root because we've got so much going on over here. So we'll try to factor. So what multiplies to negative 2 multiplies to c, and some stuff 4. Well, no integer answers work, so it can't be factored. And actually, I don't know, we didn't do any of those take the square roots of both sides, right? Like we've got an x here, an x squared here, and it just doesn't work out that well, right? So if you can't take the square root of both sides right away and you can't factor, that's where method 3 and 4 come in. Okay, so let's go back to that do now question. We have x plus 5 squared equals 10. All we had to do to solve this one was take the square root of both sides and then subtract 5 from both sides, right? Well, because that's kind of set up in a nice way so we can just take the square root of both sides to undo the square. But this side unfortunately isn't all something squared, and there's more than one x, so what do we do? Well, the idea of completing the square means maybe like, where did this come from, right? A reminder that x plus 5 squared is x plus 5 times x plus 5. Right? And someone might have taken this and put it here so we can take the square root. But even one step further, maybe they started at this one. Because if I'm x times x, x squared, 5 times x, x times 5, 10x, 5 times 5 is 25. So this equals this, which equals this. And what this is called is a perfect square trinomial. And the reason we call it a perfect square trinomial is because when you factor this, you get the same thing in both parentheses. Another way to think is 5 times 5 is 25, and 5 plus 5 is 10. So this is a perfect square. We saw those earlier in chapter 7. And I can take something times itself and write it as something squared. So perfect square trinomials are pretty awesome because if we can write down what times what is this and this, right here and here, and then we can take the square root of both sides. So if we have perfect squares, trinomial on one side, we can try to go to this phase and this phase and then do what we did in the do now. Okay. So still got a little bit more. Okay. So I want to show you an example. Okay. We have x squared plus 8x plus 16 equals 8. If we wanted to try to factor it, we have to subtract 8 from both sides and get it equal to 0. And then we could try to factor it and use the zero product property. But one thing you can do first is to check to see if it is a perfect square trinomial. Okay, so what you do is there a number something times something that equals the c value? And is it that same something plus something that equals the b value? So in this case, is there something times something that equals 16, and it's that same number plus itself will equal 8. And everyone should see that 4 times 4 and 4 plus 4 get our two answers. So since this is a perfect square, and we know that 4 and 4 works, I can go like this. Multiplies to 16, adds to 8, 4 and 4, x squared. And then if you ever have anything squared, you can just write it as, if you have anything times itself, you can write it as anything times itself squared. And then, because we have something squared like the do now we talked about last class, you can take the square root of both sides and get x by itself. And we found our two answers. So if we have a perfect square and we noticed it, we can get to this step, which is x plus 4 squared equals 8, and then we can take the square root, which we take from method 2, right? Taking the square root of both sides. If we have a perfect square, we can work our way down. Okay? So perfect square trinomials are awesome. They can kind of combine factoring and take the square root. And they, it works really good. So that's part 1. Here we go. So we weren't actually completing the square yet because this is already a perfect square. But that's going to be our idea here. So this is completing the square part 2. And we would spend a lot more time building our understanding of this, and I would never do this in 2 days, but we're going to do it. I would never do this in 1 day, but we're going to do it. Usually I stretch it out for a couple of days. So let's complete square part 2. What happens if a quadratic is not a perfect square? How could you solve it, right? So right now, this can't be factored to find what makes it equal to 0. And it doesn't say like something x plus something squared. There's not the same number that multiplies to -2 that adds to 4. It's not the same number. So what do we do? Okay, this is my take on completing the square. So let's think for a second. We have a b, right, which is 4. Is it the same number we can get to adds to 4? Well, that's easy, right? And then something times something. Well, if we take the things that add to get 4, what if we use them to multiply to get 4? Right? So 2 times 2, sorry, not multiply 4, but take those two things that add to 4. What if this was a 4, right? If this was 4x plus 4, x squared plus 4x plus 4, then this is a perfect square, right? Check this out, right? So what multiplies to 4 and adds to 4, that's 2 and 2. So I could write this as x plus 2 times x plus 2, right? And then I can write that as x plus 2 all squared. And then I could take the square root of both sides. But unfortunately, it's a -2 and not a +4. But we could actually make it a +4 because there's some rules in algebra that allow us to do things to both sides of an equation. So if I wanted to turn this -2 into a +4, what could I do to both sides of an equation to get this -2 into a +4? Well, -2 plus what will get us 4? We added 6. And we are okay in algebra as long as you do it to both sides of the equation. So we'll add 6 to both sides. And -2 plus 6 is 4. But to keep it balanced, we got to keep our 6. Do it to both sides. And 6. Bring that down to 6. And now, where we couldn't factor it, and it wasn't a perfect square, so we couldn't take the square root of it now. But because we added 6 to both sides to make this a perfect square, or completing the square, we can now solve it for x. So we have x plus 2 all equals 6. So we'll just take the square root of both sides. Then we got x plus 2 equals positive or negative square root of 6. And then we have our answer. Okay, we completed the square, and that's method 3, where we try to make a perfect square trinomial by doing something to both sides of an equation. So it's kind of factoring, but really not. It's really just finding the correct number here based off the b value, and then doing something to both sides. So we'll take a look at another one. All right. We have x squared plus 6x plus 15 equals 11. Okay. We're going to try to complete the square. Take a look at our b term. What two numbers add to get 6? Same number, right? Well, that's an easy one, right? 3 plus 3 equals 6. Okay, so this, to make it a perfect square, would have to be 3 times 3, which is 9. But it's a 15. Really wish it was a 9. Well, is there anything we could do to both sides that would turn this 15 into a 9? Well, yeah, I could just take away 6 to 15, and that would turn to a 9, but I got to do it to both sides. Okay, and now, what times what equals 9 that sums to 6? Well, that's 3 and 3, so x plus 3 times x plus 3 equals 5. And then we can write that as x plus 3 all squared equals 5. And then you can take the square root of both sides, right? Now we can write this as x plus 3 equals positive or negative square root of 5. And then take away 3 from both sides. So we get x equals positive or negative square root of 5 minus 3. Completed the square. So our big key is figuring out the correct c value. And I would have you discover it and turn and talk to your neighbor. But for right now, what you do is you take, so the correct c value for perfect squares are equal to the b value divided by 2 squared. So we take our 6, we have it, which is 3, and 3 squared is 9. So that's the way how to find the correct c, to make it a perfect square. And then we just have to think about what do we do to this number to get it down to a 6, and we just take away 6 from both sides. Okay, so I don't know where we are in time, but we'll see. So here we go. We have x squared plus 6x equals 5. So we want to kind of complete the square. So here's our b term, right, which is 6. And to find the correct c term, we're going to do it, take the b, divide it by 2, and square it. We already know this is supposed to be 9, right, from our last one. So what do I need to do both sides to get this plus 9? Well, there's no c term here currently, so I'm going to add 9 to this, and I'll do it to both sides. Oh, 14. Yeah, 14. So now this is a perfect square, so I can write it as x plus 3 times x plus 3 on this side. Instead of equaling 5, because we added 9 to both sides to make it so we could do this, we're at 14. Then we do x plus 3 all squared equals 14. Then we take the square root of both sides, which I'm not going to show for time-wise. I'll do it for time-wise. Because I want the notes. So you take the square root, Okay. And then you got x plus 3 equals positive or negative square root of 14. And then just take away 3. And there is no other, well, there's one other way for you to find the exact solution to what squared plus 6 times what equals 5. And this is crazy. This is what it is. I know. It's nuts. What squared plus 6 times what equals 5? It's both positive square root of 14, positive square root of 14 minus 3, and negative square root of 14. It's an irrational number that never ends and never repeats. Okay. Now would be a great time to pause and see if you can figure it out. I'm going to keep going for time-wise. I'll go ahead and pause me and try 4. I'm going to keep going. Okay, so I'm going to try to complete the square here. Okay, so I'm going to take my b value. I'm going to divide it by 2 and square it to find the correct c when it's an x squared. So we got to take half of b and square it. So negative 6 squared, 36. So what plus what is negative 12 that multiplies to 36? It's negative 6 times negative 6, and negative 6 plus negative 6 gets you here. All right, currently it's a 4. We really want to turn it into a 36, and it's okay to do that as long as we do it to both sides. So we'll just add the 32 to both sides. This side becomes 42. Now we have an equivalent equation. And what times what multiplies to 36 and adds to negative 12? Well, that's negative 6 and negative 6. And we can write this as, whoop, time out there. Computer timed out. Okay. And then that's x minus 6 squared equals 42. And then you can take, I'll just keep going down low, you can take the square root of both sides. Which cancels out this squared. So x minus 6, we're almost there, plus or minus the square root of 42. Add 6, add 6. You get x equals positive or negative square root of 42 plus 6. So those are our two answers to that equation. All right, that's the lesson called completing the square. I would never do it this fast. I would spend 2 or 3 days on it maybe, just so you build your understanding. But that is how we complete the square. Classwork and homework is right here. It's on page 579. It's numbers 5, 8, 9, and 10, keeping it simple. The answers are here for you to see. So give it your best shot. Try to complete the square. Look back at the examples. Okay? You can always watch a separate video on it, but that's me explaining it. So, and we'll learn the fourth method on the next class.